I like that one. All right, so I gave you an assignment at the end of class last time. Remember what it was? Right, to think about how you find things in semantic memory. So you've got semantic memories for all sorts of things. So this is memories for facts. So far we've been talking about memories for events. We're going to switch gears and talk about memories for facts. So George Washington was the first president of the United States. That's a fact, right? So if I ask you who was the first president of the United States, you can pop off with George Washington. If I ask you other facts, what's the highest waterfall in the world? Anybody know?
Angel Falls.
Angel Falls. Yeah, Victoria Falls may be the largest, like in volume, but Angel Falls is the highest. Somebody besides Steve, where is it located? Venezuela, yeah. Who's it named after? Shoot. It's named after somebody, yeah. So I always assumed it was named after, the angels because it's so tall, but it's named after a guy named Angel who found, I guess, first European who found it and named it.
Actually, after we talked about this last semester, have you ever read the book Dreamcatcher by Stephen King?
Uh-uh.
The main character has perfect memory, and what he does, he goes into a library in his brain, and that's how he catalogs everything.
Everything according to date or according to topic or?
I don't know. It's complicated. It's a big library.
It's in the library.
He gets locked in, and then he goes into a coma or something.
Okay, that's interesting. Maybe I'll have to read that.
It's also a movie if you don't want to spend the time reading a book.
I need more books to read. I don't know. I like to read, and I read too quickly, I guess. Where was I going with this? Oh, semantic memory. So how do you organize your semantic memory? Is it like a library? Or is it like a big pile, like, some professor's offices? Or does it look like this? Is it nice and organized? What do you think? Danny?
I kind of hold with association.
Okay. So organized by topic, maybe, instead of by Dewey Decimal? Yeah. Okay. Ariel?
People's organize it differently. You have scatterbrains, and then you have people who are very precise.
Okay. So different people organize it differently?
Imagine it, organized like a web, kind of, where things are they're organized and connected, but they're not unique.
Okay. All right. So sort of a spreading network of activation. Okay. Any other ideas?
That's partially what I meant by association.
Yeah. No. So it's sort of organized by topic. So it's probably not an index system. It's probably not like a library per se, or like a computer hard drive, right? So these are called addressing systems. So if I wanted to go find the Stephen King book, how would I do that in the library? What would I look under? Dreams? No, I'd look under King, right? So I'd go to the fiction section, and then that's organized by author first name, right? Sorry, author last name, and then first name, and then whatever the other numbers are. I have no idea how the Dewey Decimal System works. All I know is that if I got the number, then I can find it on the shelf. So what if I'm off a little bit? So let's say King is K162, and I get to K163. Am I likely to get horror, science fiction sort of stuff that Stephen King writes? What am I likely to get?
In the mystery section.
Could be anything. So it could be mystery. So if it's organized by topic, but the way that the library organizes it is by author last name. So it's probably going to be close to King. Kingston. Okay. So Barbara Kingston novels about bodice busters or something like that. Some romance novel, and that's likely to be right next to Stephen King, right? So is that how our memory actually works? No, not so much. So your memory, your semantic memory clearly doesn't work like this. Because A, the more that you know, the longer it should take you to find things. So you may be like this character from the Stephen King novel, where he's got everything in there, and so it takes forever to find anything, right? So it's pretty easy to find things, well, if you know that they're there in my kids' elementary school library, because they don't have a lot of books. They've got a lot of, Judy Blume kind of books. But in the Lee Library here on campus, it takes a bit longer to find things, just because it takes longer to walk to this proper place, because it's so large, right? So the idea is that the more you know, the longer it should take with an addressing system, but it doesn't actually. So the more that you learn, it doesn't take you any longer to find things. In fact, it takes you less time to find things if you learn more stuff. Also, slight errors. So if I'm off by one number in the Dewey Decimal System, I'm going to get the romance novels instead of the Stephen King that I'm looking for. But usually for us, we get close with our semantic memory. So we come up with something like Victoria Falls instead of Angel Falls. Still a waterfall, still related, but not exactly the right thing. So largest waterfall, not tallest waterfall. So it doesn't take us longer to remember things as we learn more, and when we make a mistake, it's typically a near miss. And even more impressive is that we can use our memories, our semantic memories, in flexible ways. So if you dropped a raw egg from the Eiffel Tower, would it break? Yes. I mean, that's stupid, right? That's obviously it's going to break. How do you know that? Anybody ever seen raw eggs thrown off the Eiffel Tower? No, not likely. I think that the French would look down their noses on that. So how do you know that it would break?
We've seen eggs drop from the break.
Okay, so we've seen eggs drop from heights. We know that when you drop an egg from, maybe 3 or 4 feet even, it's going to break. This is much taller than 3 or 4 feet. So you've got all of this information in there. You know about eggs. You know about the properties of eggs. You know about the properties of the Eiffel Tower. You can combine this information and use it in a flexible way. So you've probably never observed this, but you know some of the relevant facts, and you've had some experience with these things. Anybody ever do egg drops as like a kid in elementary school or as a Cub Scout and stuff like that? So these are fun, right? What's the best packing material for egg drops? Styrofoam?
Is stuff that use floral designs where you stick flowers in them?
Oh, yeah?
Yeah, that stuff like it's usually green.
Yeah, sort of the floral blocks.
Yeah.
Jar of peanut butter.
A jar of peanut butter?
Peanut butter, and then there's no impact to the egg.
Oh, okay. That's an interesting way to do it. I've never thought of that. Popcorn always worked for me, like actual popcorn, not like the popcorn styrofoam peanuts. As a Cub Scout, I didn't realize that this was unusual because I didn't know any better, but they had, Cub Scout Day Camp, and as part of the culminating event in Cub Scout Day Camp was the egg drop. And they dropped eggs out of an airplane. I didn't realize that was unusual until years later. Looking back, I'm like, that's kind of weird that they did that. Usually they drop them from like a ladder or something. But no, where they had the Cub Scout Day Camp was right next to the municipal airport, and apparently somebody knew a guy with an airplane, so they'd fly low and drop them, just throw them out the door. It was pretty cool. You just run along the field and find yours. You had to paint it bright orange in order to find it. But it was pretty cool. Mine broke every year. I never used popcorn. All right, so we know some things about eggs. We know some things about heights and the Eiffel Tower, and we can combine these things in flexible ways. So we need to be able to account for that. So theories of how semantic memory is actually organized need to account for ready access to lots of information. So if I come up with some random question about, is it unusual to drop eggs out of airplanes, then you can see that, yes, that is somewhat unusual. You also need to be able to access the relevant information when the crucial information is not stored. So if you've never observed an egg being thrown off of the Eiffel Tower, you need to be able to get to the stuff that's related to that. All right, so part of the way that we do this is through categorization. So there are a couple of ideas as to how things are categorized in the brain. So I'm going to ask you a question about an object. It's a simple question. The question's already up there. There's the object. What is it? Okay, pretty easy. Have you ever seen this apple before? No. Okay. But do you know something about it? Does it have seeds, for example? Yeah, most likely. Does it have lungs? Very unlikely. All right, so if you've never seen this apple before, how do you know that it doesn't have lungs? Experience. Okay. Danny?
Induction. From what I know about apples, I've never encountered an apple.
Okay, so you've never encountered an apple with lungs. What if I showed you something that looked an awful lot like an apple but wasn't an apple? What if I said that it was a plick? So this is what a plick looks like. There's a stem up there, and plicks are somewhere between apples and upside-down pears. So from what you know about apples and pears, is a plick likely to have lungs? No. Okay. So you can take what you already know, and you can, through induction, like Danny says, sort of induce and reason through it and say, no, it's probably similar to apples and pears, and those don't have lungs, so I'm going to say, no, plicks don't have lungs. All right, okay. So what you need to do in order to answer this question, so I show you the apple. You need to compare the concept to others. So compare this object to other things that you have stored in semantic memory. Is it like a guitar? Is it like a piano? Is it like a dog? Is it like a fruitcake? Et cetera, et cetera, et cetera. So we've talked before about object identification and how we identify objects. So we're not really going to talk about the identification of the object itself. Let's assume that that's already happened, that we've identified this as an apple. Now we need to compare and see, okay, so this looks like an apple. It matches to this concept. And from that concept, now we've got this semantic network, right? Now we've got this web of other related facts. And we can figure out, okay, what are the properties of the apple? So we need to make a couple of distinctions here between categories and exemplars. So this right here is an exemplar of the category apple. So apple is sort of the broad bin, it's sort of the broad group, and apple is this is a single member of that group. So other examples of categories and exemplars. Markers, this is an exemplar of markers. It's pretty simple, right? So you've got this group, and then exemplars are individuals within that group. So category is a group of objects that have something in common, and then an exemplar is a particular instance of a category. You can be more broad than marker. This could be the category writing implements, and markers can be an exemplar of writing implements. A concept, on the other hand, is a mental representation with which you compare a novel object to know its properties. So a concept is sort of how we store these things in our head. So you've got a concept of either markers or writing implements. And you need to compare the incoming information against those concepts to be able to generalize and know what you do with something like this. So if I give you a marker that looks different than any other marker, well, actually, that looks similar to other markers, but you've never seen that particular marker before, you'll know what to do with it. Little kids generalize all the time, right? So my daughter, when she comes to campus, she's 19 months old, and when she sees pictures of the mascot, like at Cougar Copy in the Marriott, there's a pretty ferocious looking mountain lion, cougar. She looks at it and says, "Kitty, meow." So for her, she generalizes. So she knows about kitties because she's got a cat at home, and he's pretty nice and tolerant and is not going to, bite her head off like a real cougar will. So she generalizes. So she's got this concept, and it's a fairly broad concept. It encompasses basically anything with fur and four legs, and they all say meow, and they're all kitties. So that's sort of overgeneralization, and we sort of narrow these things down with experience. All right, so the question is, what do our concepts look like? Do they look like categories? Do they look like exemplars? Do they look like pictures? Do they look like semantic properties? What do they look like? How do we store this information in our minds? How do we go about storing the semantic information? So there are sort of two ways to look at this. The classical way is basically through rules. So you've got a set of characteristics, a set of criteria that define an apple, for example, or a grandmother. So how would you define a grandmother? Well, these are kind of likely criteria. So your grandmother is female and is a parent of one of your parents, right? So your biological grandmother is a parent of your biological parents. Does that satisfy all the criteria? Can you think of any other criteria for grandmothers?
Loving.
Yeah, but I mean, technically, no, you don't need to be loving to be a grandmother. You just need to have offspring who have offspring and be female, right? So if I ask you how grandmothery are these women, Barbara Bush, Whoopi Goldberg, and Dr. Ruth, does that make sense? Are some of these more grandmothery than others? When you think of grandmothers, do you think of Whoopi Goldberg? No, probably not. Do you think of somebody who looks a bit more like Barbara Bush? White hair, probably bakes cookies. Maybe. So if it were just categories, if it was just a definition, would this question even make any sense? No, it wouldn't, right? So the question should be, do these women all have grandchildren? And if so, then yes, they're grandmothers. And asking how grandmothery are they, it's like, how pregnant are you? Well, you're either pregnant or not, right? So that's sort of a binary sort of thing. So with grandmothers, you either are a grandmother or you're not. You can't really have degrees of grandmotherness. So data like this, so this is sort of an anecdote, but you can ask people, bring people into the lab and give them a set of bird names, for example, and have them rate how birdy are these things. And ostriches rate pretty low on birdiness, whereas robins and sparrows rate pretty high on birdiness. So that sounds sort of funny, but if you think about it, so think of a bird. You're probably thinking of something about yay big that looks a lot like a robin, right? So robins are sort of the prototypical bird, and you're probably not thinking of a penguin. Anybody think of a penguin when I said think of a bird? No, wait, okay, you're weird.
It's my favorite bird.
What's that?
It's my favorite animal.
Oh, okay, penguins are your favorite bird. So it's pretty atypical, though. Not usually. So you're the only person in here who thought of birds. So you're atypical. Sorry, Jessica. So you get what are called typicality effects. So you can ask people. So fun joke is, say, think of a color, and then think of a tool. And how many of you are thinking of a red hammer? Only one? Okay, so I've tipped you guys off. You're thinking of unusual colors and tools, aren't you? Yeah. So unsuspecting people who don't know that you're a psychology major, have them think of a color and a tool, and pretty often, I'm not going to say it, well, at least the majority of the time, people are going to think of red, and they're going to think of a hammer. Think of an odd number. Usually people think of 3, 5, or 7 for odd numbers. So sort of in that range. Although there are an infinite number of odd numbers, most people think of 3, 5, or 7. Those are sort of typical odd numbers. So you get these typicality effects. And typicality effects will affect how you reason about things. So for example, if you know that robins like to eat onions, this is weird things that robins do. They like to eat fruit and berries, and onions if they can get them. So do you think starlings like to eat onions? If you know this about robins, how likely are starlings to like the same things that robins like? What do you think? Versus if you know that owls like to eat onions, and then you ask, do you think starlings like to eat onions?
What's a starling?
Yeah, it's a starling.
Oh my goodness.
From the city, I don't know.
You've seen starlings. Let me give you the lesson on starlings.
Like rats. Oh,
They're
that's
pets.
gross.
They're everywhere.
Those tiny ones that are always.
All right, here we go. What's a starling? That's great. All right, European starlings are a menace to the ecosystem. So it turns out that some genius back in the 1800s, 1820-ish, thought that, all of the birds mentioned in Shakespeare's sonnets should be present in New York Central Park. And Shakespeare mentioned starlings, and they were not there. These are European starlings. They're not indigenous to North America. And so this genius brought over 20 breeding pairs of starlings and let them go in Central Park. And they have spread like a disease across the entire continent. They're everywhere. They outcompete. So they're an invasive species, really. They outcompete all of the native species, and they just continue to spread. So you've probably seen these things flocking. It's like the Alfred Hitchcock birds. Danny?
A lot of states actually offer a reward if you kill them.
Yeah.
Nice.
Yeah, they're a vermin. This is a female. Looks kind of nappy. No, the males are actually kind of pretty. So this is a drawing of a male. Let's see if you can find a photo of a male. Here you go. Starlings are interesting in that they have a syrinx. So instead of a larynx, where you can control only one set of vocal cords, they've actually got two independent sets of vocal cords, so they can literally sing two songs at once. They learn a new song every spring, and they're pretty impressive. The songs, if you stop to listen to them, they come up with really brilliant kinds of songs. You can tell that this is a male because the feathers are not quite brown; they're kind of greenish, and the beak is nice, bright yellow. If it's got more circulating testosterone, the beaks are yellower. So as the days are getting longer now, if you pay attention to the starlings, you'll notice that the males have yellower beaks as sort of spring is approaching. They're a great model for language learning, it turns out. So they have neurogenesis. They grow new neurons in their song nuclei, so these motor nuclei, where they actually grow and shrink according to how much they know, how complicated their songs are. I know all this because in my graduate program, I shared an office with somebody who was in a lab where they studied starlings. They would go out to the university farm. Johns Hopkins University has a farm, it turns out. So they'd go out to the farm and catch these starlings. And so they bring them into the lab. They do all these sort of behavioral manipulations with them or pharmacological manipulations, stuff like that. And then they would usually sacrifice the birds and take a look at the brain and see what's going on in the brains. And so that was the end result of all these wild starlings that they were catching. And this farmer who managed the farm was asking my friend, what are you going to do with these birds? Oh, we're going to take them back to the lab. We're going to study them. And then what do you do with them? Oh, we sacrifice them and look at their brains. So because you don't really know, talking to somebody, if they're going to be grossed out or horrified that you're chopping off bird heads. But this guy was not. He was pretty pleased with that. He said, "You can kill every damn one of them for all I care." All right, so that's a starling. So now that you know about starlings, let's see if it generalizes to robins. So now you know about starlings, and you know that starlings learn new songs and things like that. They look similar to robins. What do you think robins do in the spring? Do you think that they learn new songs? Do you think that this sort of thing generalizes to robins? Versus owls. Do you think owls learn new songs? What do you think is more likely? Robins learning new songs or owls learning new songs? Robins. Okay. So this is what a typicality effect is, that starlings look a lot more like robins, they behave a lot more like robins, and so you would assume that this behavior transfers into new song learning. I don't actually know anything about robins. Robins are nice birds, and they don't study them in the labs. So I've got no idea whether robins learn new songs or not. But you would sort of expect that to be the case. So your semantic organization allows you to generalize readily to robins, not so much to owls, because owls are sort of over here. They're sort of weakly connected. They're still birds, right? So if it was just a definition, then starlings are birds, owls are birds, so therefore the things that apply to starlings probably apply to owls, but maybe not so much. So This affects categorization. So more typical exemplars, more typical instances of the category come to mind more readily. So if I ask you to name a piece of furniture, you're likely to say sofa. If I ask you to, let's see, what are some other categories? We've done odd numbers and colors and tools. Name cars. Okay, name a car. This only works if you know names of cars. Mercedes, Subaru. Nobody named, a tank or a Veyron or things like that. So uncommon things don't get named. What are other categories? Sports. Name a sport. Baseball, basketball, football. Cricket doesn't get mentioned. That's not really a sport, right? Curling, bowling, those things don't get mentioned because they're not really sports, right? But, if you look at the definition of a sport, yes, they qualify, but they're not very typical. So you're actually faster to verify more typical instances. And it strikes me, standing here right now, that this is sort of circular. So how do you know if something is typical? Okay, frequency of the response and maybe how quickly people endorse these as being members. So this is just saying the same thing, right? So that you're faster at identifying typical things, but it's typical because that you say it more often. Maybe not that you're faster at identifying it. So this sort of brings up how do we organize these things? How do we really think about these things? And are they the same for everybody? Turns out they're probably not the same for everybody. Turns out that the way that you think about some things is going to be different than how other people think about the same kinds of categories. That we don't all categorize everything exactly the same. So, for example, let me give you the general and then I'll give you an example. So in general, the basic level is sort of where we enter, what we think about things. So if I say birds, is birds the basic level or is robins the basic level? Probably birds is your basic level. And then the subordinate level is going to include robins, starlings, owls, ostriches, penguins, things like that. So all of the exemplars, all of the instances of the category, but the category itself is going to be birds. So categories are your basic level, and then you have subordinate levels below that. And then superordinate levels. So the superordinate level for birds is going to be animals. So the basic level is the most inclusive, but members still share most of their features. So for example, most birds are winged, lay eggs, etc., etc. So it's defined as what characteristics do the members of this category share in common. So birds all have feathers, they all lay eggs, they're warm-blooded, etc. The superordinate level shares more characteristics with other things that are not in the same basic level. So for example, animals do not all share the same features as birds. So not all animals have wings, not all animals have feathers. Some are warm-blooded, some are not. And then the subordinate level goes below that, below the basic level. So categories are less abstract than the basic level. So for example, wrens are all very similar, but only a few features differentiate a house wren from a marsh wren. Another example, trees. So maybe the basic level for trees is maples, birch, oak, pine trees, aspen trees, etc. So the types of trees that you see around here. And then subordinate level are going to be silver maple or a sugar maple, river birch, white birch, red oak, white oak, scrub oak, things like that. And then the superordinate level is trees. Now, this only works if you know names of trees. If you can't tell the difference between a maple and a birch, well then your basic level is going to be trees and your subordinate level is going to be maples and birches. Ariel?
Is there a name for a level below the subordinate?
So that would be probably specific exemplars.
Well, you could say a new white birch versus an old white birch.
Yeah, those are going to be specific exemplars within these categories. So these apply to categories, And then each of these contains individual instances. So individual trees are going to be included in here. So if you need to go down farther, then maybe your basic level, maybe you need to shift up your basic level. So if you're a tree expert, what do you call a tree expert? Arborologist? You're a tree doctor. Not that kind of doctor, you're a tree doctor. And so maybe this is the basic level. Or maybe with cars, maybe your basic level is cars, and then the subordinate level is going to be passenger cars and trucks and sports cars and convertibles and things like that. And that's all you know about cars. But if you're a Top Gear fan, any Top Gear fans in here? Only Danny? Oh, you guys. Funniest show on Netflix is Top Gear. It's not really on television. What's that?
The British version.
The British version, yeah. I've never even deigned to stoop so low as to watch the American version. The British version is hilarious, mostly because of the presenters, the three guys who host the show. They're just hilarious. So you should watch it. So anyhow, but they like to have fast cars. So the episode that I watched last night had a new Lamborghini on it. What was it called? It was called Aventador. Yes, who said that? Okay. What do you know about the Aventador? More than you should. Okay, tell us about it.
I don't know, it's like the replacement for the Murcielago. I guess it's just like most Lamborghinis, like bigger, louder, faster, more like obnoxious looking.
I think it looks pretty, well, yeah, it is pretty obnoxious looking. It looks like a stealth fighter, basically. So it's sort of all angular. It's got a V12 engines and like a
700 and something, like 740 horsepower.
Yeah, something ridiculous. This huge top speed. It gets 0 to 60 in like 2.5 seconds or something like that. It's ridiculously over the top, this car. But if you're a car fan, as some of us apparently are, then you can rattle off things like Aventador and Murcielago, and you know what that is. So that may be your subordinate level. And your basic level is going to be Lamborghinis. And then your superordinate level is going to be hypercars or supercars or whatever. So for most of us, we're going to be up a level from that. We're going to say it's a super fast, expensive looking sports car, and that's going to be our subordinate level. So different people are going to have different basic levels.
So is then there like a superordinate level?
Yeah, so you can contain these things inside of, they're mechanical objects, so they're man-made objects or something like that. And then you can have a superordinate level above that with real objects and imaginary objects. And above that, you can have different levels of these things. The idea is that the basic level is where you enter at. So if I say cars, the first thing that you think of is going to be your basic level, and then you can have more specific or less specific from that. So some people argue that the basic level is psychologically privileged, meaning that that's what we usually use when we're thinking about things. So if you think about cars, you think about a car going down the road, the basic level is what you're using when you're doing that imagining event. People usually use the basic category in language, and people are faster to verify an object name at the basic level than at the superordinate and the subordinate level. All right, so the basic level depends on your expertise. So if you're a carpenter, then that's a ball peen hammer. If you're a non-carpenter, then it's just a hammer, right? So where you enter at depends on your expertise. So we're mostly out of time. So we'll pick up next time. That's good. So we're most of the way through this, or halfway through this at least. So we'll pick up next time with figuring out, because we asked this question and we really haven't addressed this question. How do we actually represent these things? So we've got a basic level, but what sort of representation captures these effects that we've been talking about?